Hello, everybody. Welcome to another discussion on dynamics. Today's topic is relative motion plus kinematic constraints. I think you guys know exactly what to do with those constraints. Just today, I just would like to clarify one thing. Okay, so you probably already heard about inextensible ropes or wires, and you heard about ground and incline. If we see such things in the mechanical system, we basically have to replace them with forces, reaction forces acting on the system. Yeah. So, for example, ground will replace with a normal force. Yeah. Inextensible rope we will replace with tension in the cable. Yeah. Okay, so today I think it will be a very easy discussion, yeah, because I'm just going to classify things you already know, in my opinion, yeah. And we're gonna do two examples, example number one, example number two. By the way, when it comes to quick reminders, there is a YouTube channel, Dynamics for Non-Dynamicists. By the way, I improved the channel a little bit. I will show you what I'm talking about in a second. Yeah, so if you go to our channel and if you click on, let's say, I don't know, this video, this is it's me talking, yeah. So this is our discussion from last Friday. I divided that video into chapters. So if you are interested only in think example number 2, you just click here and you have our solution for example number 2, okay? Just I thought that it would be nicer for you. It will speed up. It will save some of your time. Okay, so that's the only new thing, and that's all. Yeah, practice makes progress. No solution manuals. Okay. Questions, or do you want to do example number 1? Example number 1. Okay. As usually, please familiarize yourself with the problem statement before we start our solution. Okay, so what do we have in here? We have our pulley system here. Yeah. And they told us that we know what happens with this end of that rope. Yeah, we know velocity and acceleration of that rope. And they told us to find velocity and acceleration of this block. Okay, and we know the geometry. We know the entire geometry. Yeah, so basically this is what I repeated these things, yeah? This is exactly what I said. So let's start our solution. Can anybody tell me how many ropes do we have? How many ropes do you see in the picture? 5. I am wondering where is the 5th one? 4th. Yeah, this will be the 4th one, okay? So I see 3. I accept like answers like 3 or 4, okay, in here. So let me maybe put some colors there, okay? So let me put, this one will be red. This first rope will be red, okay? This one will be green. And this one will be blue. Okay. So let's say that for now we have 3 ropes. Okay, so let's call them, and the red rope will have length 1. Okay, which is constant because these ropes are inextensible. Rope number 2 is also constant. I mean, its length is constant and it's equal to L2. And blue rope is also its length is also constant. Yeah, there will be 4th rope, okay, but it will come into a picture in a second, okay. So, okay. So we have, this is how I solve those problems. See, I just ask myself a question, how many ropes do we have? How many ropes do we have? And let's say that the answer is 3, okay? Or maybe 4. 4 is okay. You already see the fourth one, yeah? Okay, now let's put this stuff, this drawing, into more mathematical formalism, okay? So I would like to define elevations of certain points. For example, I would like to define elevation of this point. Or maybe even better, let us define datum first. So I want to move this thing. I actually want to get rid of this thing. So this will be our datum, okay? Here. This is our datum. And I would like to define this elevation as YB. Okay. I would like to define this elevation as elevation of point C. This one as obviously YD. This day will have elevation YA. Okay, and also let's define maybe this thing. Let's define this thing also as YG. Okay. So that's that when it comes to drawing our arrows. And now let's maybe express length of rope 1 in terms of these y's, in terms of these elevations. Okay, so anybody wanna tell me how long is rope, red rope, based on the picture? Or maybe I can start, okay? I will start and you can tell me the second one. So I think that this part of the rope, this part, is YG minus YD. And this part of the rope is YA minus YD. Okay, so anybody want to go for the green rope? How long is this distance, in other words? YD minus YC. This one? This one? Yeah. Minus YC. Okay, I heard a little bit of impatience in your voice, so you can go for this one as well. Oh, YG minus YC. Okay, I asked you for the different one and you said the second one. Okay, you were right. Okay, YG minus YC. Okay, and blue one is following. Yeah, it doesn't matter. Okay, so I believe that long part of the blue one will be basically YG. Yeah, and these three little ones are defined by YB. So this is equal to plus 3 YB. Okay. So let me now. Any questions? What happened on the board? Yeah. So far easy. Yeah. I like to disassemble those problems into such simple steps. Okay. So now let me maybe organize those things in parentheses. Okay. So L1 is equal to YA minus 2YD plus YG. L2 is equal to yd minus 2yc plus yg. And the third one is 3yb plus yg. Great, we have our expressions for lengths. We know how our lengths change, okay? And by the way, all of those lengths are constant, yeah? Okay, but they ask us to find velocity and acceleration, okay? So what I propose just differentiating each of these equations once, okay? Just to get to the velocity level, okay? And since all of our lengths are constant, we will have 3 zeros in here, right? 0, 0, 0. And I believe that I can do a little bit of magic because I can basically copy this and I can add everywhere a dot, yeah? Some of you can also do it. And those of you who use pen and paper, sorry. Yeah. And next step, guys, maybe, you know, even instead of y dot, let's use maybe v, okay? So I'm gonna even go like that. I mean, I'm going to put it here. So it will be velocity A, velocity D, velocity G, velocity D, velocity C, G, G. Okay, so we are on the velocity level. So let's see how many unknowns do we have, okay? I believe that we only know velocity A, yeah? So we'll mark it with green, yeah? So this is what we know. And we have 3 unknowns, I believe, because we don't know velocity G, velocity D, velocity G, and velocity C, and velocity B even. Wow, so we have 3 equations and 4 unknowns. Yep, we need 4th equation, and this is exactly what Jason said at the very beginning. There is a hidden 4th rope. Yeah. How are you doing, guys, with writing? Do you want like 30 seconds? Yeah, I can wait. 30 seconds? Yeah. So yeah, so we have 3 equations and 4 unknowns. It's not solvable. Yes, you know that. Yeah, we need to have exactly the same number of equations as unknowns, or we need sometimes more equations than unknowns. This is also solvable. Yeah. So there's a hidden 4th rope. Jason already answered that question because that rope is in here. It will be orange, okay? BC. So that will be our 4th rope, L4. This is equal to constant. And what does that imply, Jason? If you wanna, do you wanna follow? Do you wanna continue? So what that rope implies? What information it gives us about point B and point C when it comes to this set of equations? Kyle? Perfect. Yeah, they are connected. Yeah. So we have our 4th equation. VB must be equal to VC. Yeah, thank you. Yeah. Yeah, and all of a sudden we have 4 equations. Yes, we have 4 equations, so it's solvable. Okay, let's solve it quickly. So I would like to. So I'm going to just number those equations. Okay, so it will be number 1, number 2, number 3, and number 4. I think I don't have to even solve it, guys, but okay, let's do it quickly, okay? I know that all of you know how to do it, and they are asking yourself what that guy is doing right now. We know how to do it, yeah? So if we plug in 4 into 3, we'll end up with such expression. VC is equal to -1/3 VG, okay? This is our equation star. Now let's plug equation star into equation 2, okay? And this is basically 0 equals to VD plus 2/3 VG plus VG, okay? So we know that VD is equal to minus 5/3 VG. What's that? What was that? Okay. Drawn. Okay, that will be in equation double star, okay? And now let's obviously plug equation number double star into equation number 1. 0 equals to VA plus 10/3 VG plus VG, okay? And triumphantly we will obtain answer for part number 1. VG is equal to minus 313 VA. Answer A, almost, okay? Almost. This is VG expressed as function of VA. Okay, in other words, VG is a function of VA. Okay, so before plugging in values, you can already plug in values, but they also ask us to find the acceleration of G. Let's do it in 1 second. What shall I do? Once we have this one, so how to find, maybe some of you can tell me what is AG. Yeah, 313 AA, exactly. Yeah, just differentiate once, yeah, to obtain this one. Okay, plug in values. Plug in values, and you can obtain that VG is equal to minus 313 times 3. So this is approximately minus 0.6923 feet per second, and it goes up, okay? And AG is equal to minus 313 times 1. This is approximately 0.2308 feet per second square. And it also goes up. AG vector points up, okay? As well as VG vector, okay? Okay, that's all, guys. Questions? I try to spend a little bit more time on that because those ropes will come back all the time, okay? So this is like one way of doing that. I usually do that approach when we have like 700 ropes in the picture. Yes, I'm kidding. Yeah, if we have like more than 3 ropes, I do that, okay? In next question, we'll have only 1 rope. Yeah. Any questions? Isabella? VB equals to VC. Oh, sure. Look, here. They are detachable, undetachable. You see? That orange one? Yeah. It's like a very rigid piece. Yeah. So once VC moves downwards, VB has no other choice. It has to go with it. If VB goes upwards, VC must follow it with the same velocity and same acceleration. I hope I answered your question, yeah? Cool. Any other questions? Clara? Yeah. From negative to positive. I do not understand the question. Excuse me. Yeah. Sure. Let's look at the picture. So remember, so look, VA, so this is our positive, VA points downwards. Sorry, VA points downwards and AA points downwards, okay? It points that way. Remember that, okay? So in here, we obtained negative value. Oh, shoot, I forgot about that minus, yes? In here, we obtained negative value, yeah? So that means that the other thing will go upwards. It must go the opposite way. Sorry for that. Yeah. I make such mistakes sometimes. Thank you for paying attention. Okay. Any other question? Please familiarize yourself with the problem statement before we start our solution. Okay, so what do we have in here? We have two blocks, yeah, block B and block A, and I believe that we know acceleration of point of block A or point A. We are going to model those blocks as points, as particles. We also know that system starts from rest, and we know that ropes are inextensible, okay? And they ask us to find interesting thing. They ask us to find AB when persons standing on the ground is looking at it, okay? So for the stationary observer, they ask us to find AB, and then they ask us to find time needed for that block to slide 0.2 meters for person sitting on A, actually, yeah? So that's interesting, yeah? So first part is for this guy. This first part is for this observer. Second part will be calculated for this observer, moving with block A. Okay, we will see what I'm talking about in a second. Okay, how many ropes do we have? Or are there any questions to the problem statement? Yeah. Okay, I have a question. How many ropes do we have? Yes, exactly. Thank you, guys. Sorry for asking. Yeah. I just wanted to, I don't know, warm you up or something. I don't know what I wanted to do. Okay, so our L is length is also constant. Yes, L is constant, and this is our rope, by the way. If you don't see it, it will be orange. Only one rope. Yeah. And let's define its length. Okay, so I believe that our datum can be here maybe. And I would like to express that rope with these three black chunks, I would say. Yeah. Let's call it XA. Okay. And maybe this one green chunk. Let's call it XB. Okay. Okay. So we clearly see that our rope consists of 3XA plus XB. Okay, let's go to velocity and acceleration levels. So we will have to do, maybe let's do it with red. So we will have to do exactly the same as last time. Let's differentiate over time once and then twice. Okay. And we will end up with 0 equal to 3 VA plus VB, and we'll end up with 0 equal to 3 AA plus AB. Okay, and we already see that our AB is equal to negative 3 AA. Yeah. Okay. And by the way, AA is 0, A0 and it's constant. Yeah, they told us here that information. Yeah, so we can already find AB. So AB is equal to negative 3 A0, and this is equal to, and this is also constant, by the way. Yeah, because A0 was constant. So since AA was pointing this way, yeah, this is A0. So we already see that AB will be pointing this way. Yeah, it will be up the incline. Yeah, because of that negative thing. Yeah. So AB up the incline. Yeah, up the incline. Okay, let's find value maybe of that thing. So AB is equal to minus 3 times 3.7, and this is approximately 11.1 meters second square. Okay, and I think that this is our answer for part A, because this is exactly what stationary observer will see. Okay. Answer part A. Okay. This is what stationary observer will see. This is seen by a stationary observer. Okay. Any questions to what happened on the board before we go to part number 2? I also have a question to you guys when it comes to logistics. I'm usually writing here in the bottom of the screen. Do you want me to actually scroll up a little bit and write like in the center? What do you prefer? Yes? Okay, I will do that. I will keep it in mind, yeah? But if I forgot, just forgive me, okay? Thank you. Delmi, there was a question? Excuse me, I didn't hear your question. Can you please speak up a little bit? I understand. Because they don't change length. They do not contribute. So what color shall I use? Maybe blue. So you're asking about this? Because they do not contribute anything from the modeling standpoint. Yes? This does not contribute anything. And by the way, this part as well. This part is unchangeable. Yeah? Is there anybody who understands that in this room? Yes, me, for example. Yeah. And I think that should be explained on the lecture. Was it explained on the lecture? It was explained on the lecture as well. So listen, Delvi. So we have like I think 20 more minutes. Can I answer that question at the very end of the problem? Okay, because I would like to finish that problem because this is my assignment for today, and then we can talk like tete-a-tete. Okay. Any other questions? Yeah, and of course, if you guys want to know that answer, you can hang out with us. No problem. Yeah. Okay. Part number 2. Okay, now we have exactly the same situation, but we are going to not to be this guy, we're going to be that guy, okay? It's exactly the same problem, but just seen from the different perspective. Okay. So I'm gonna write it down. The same situation. This time seen from block A perspective. Block A is in motion, yes? So it's a moving observer. Okay. So in other words, how to find A relative? How to find? Yeah, we need to speak mathematics, yes? So how to find A relative? Okay, or maybe A rel. A rel, okay? So I believe that yesterday in the lecture, Professor Sunny wrote down such equation that AA can be always expressed as AB plus A seen from B. Yeah, do you remember that expression? So we can find AAB equal to AA minus AB. Okay, I forgot. I'm sorry. I should scroll up, yes. Okay. So this is our A relative. Okay, this is A seen when you sit on B and you are part of that motion. Okay, so let's plug in our values. So I believe that AA was 0, sorry, A0, and AB was minus 3A0. So we will end up with 4A0. Okay, and by the way, this is also constant. Yeah, since A0 was constant. Since A0 is constant. Okay, great. So, but it's not what they ask us for. We just found that A rel is constant, yes? And it's equal to 4A0. But they ask us for something else. They ask us for time needed to move distance point 2, okay? And now this is something that actually I had to stop a little bit when I was solving that problem, because that's actually something really cool for me. Do you remember, guys, when we said that we like when acceleration is constant? Yeah, because then we don't have to integrate, because we have like ready to go expressions. Yeah, do you remember that projectile motion we're doing? Yeah. So it turned out that these expressions are valid for every coordinate system. It's not only valid for Cartesian. It's valid for tangential, normal tangential, valid for polar coordinate system, and also when it comes to relative motion. So they asked us to find time. So I would like to integrate twice, okay? And since A relative is constant, we can write such expression. V relative is equal to V relative 0 plus A rel t, yeah? And X rel, so distance relative, is equal to X rel initial plus V relative initial t plus 1/2 A relative t squared. Isn't it crazy that every time acceleration is constant, regardless of coordinate system, you can always write down these three equations in that coordinate system, even if it comes to relative motion? Yes, Kyle?
Isn't the A realm we found relative to the block B?
Doesn't matter. Yeah. I can. So okay, I can do it. Yeah, but what I am fishing for is the magnitude anyway, because that's a good point. Yeah, because if acceleration relative to b is minus relative to a, yeah. So basically, you're right. So you want me to write that, yeah? A, b relative to a, yeah. So that will be minus 4a0. Yeah, exactly. Yeah. However, let's go for magnitude anyway. Okay, let's go for magnitude anyway, because I care about the distance covered. Okay, so can you guys tell me what that value is? Or actually what that value is? So what they ask us to find, that would be 0.2, yes? Yeah, because they ask us to find, that this is the relative distance that they ask us to plug in here, yes? How about this one? Can you tell me what is v relative 0? Why? From rest, exactly. And we can choose this 0, you can set up this as 0, yes? Okay, but we can choose beginning of our coordinate system in a smart way. And this thing will be 4a0. Okay, so we are almost there. 0.2 is equal to 1/2 4a0 t squared. Let's say t star. Okay, let's find t star. T star is equal to 0.4 divided by 4a0 square root. Plug in values. I think that would be, wait a second, 3.7 square root. Grab your calculators. You don't have to because I did it yesterday. And our t star is equal to approximately 0.1644 seconds. Yeah. Okay, that's it. This is answer part B. Answer B. Any questions? Yeah. Isn't it interesting? I don't know. I find it interesting, actually, guys. This thing that regardless of the coordinate system, if acceleration is constant, we can write down these two other things in that coordinate system, yeah, or in relative motion. I find it really interesting. Yeah. Okay. Do you want to go, or do you want to hang out here and listen to the answer of the Delmi question? Do you want to hang out here? Yeah. Yeah. Okay. So I'm just going to do two drawings, Delmi. Okay. So, okay, very quickly. So, and this is like once and for all. Okay, it would be like 2 minutes long answer, but it will answer it clearly. Okay. So imagine that we start. Look, Delmi, we start with such situation. Okay. These blocks are here. And if I remember correctly, okay, so 2 are here and 2 are here. Okay, so this one is here, this one is here, this one is here, and this one is here. Okay, so now let's see. Okay, if I do something, I should do it correctly. Yes, so let me do it like that. Or you know what, guys? So maybe let's do it because I don't want to keep you here. For those of you who want to go, you can go, okay? And if you want to stay here, you can stay. Yeah. So just please leave in silence, okay? Because I will be talking. Nobody. Okay, I like that. Thank you. Okay. So this is like, let's say, time instant 0, okay? And now after a while, then let's say, I don't know, what is your favorite number? 2. Okay, so it will be 3. 3 seconds. 3 seconds. Okay. So look, this guy. Okay, so that line is will not change. Okay, I will put that line in here. This is our starting point. Okay. After a while, the big block will be here. Do you agree? Okay, and small block will be, let's say, I screwed it up, yes. Wait a second, no. That big block will be here, okay? Let's say. It will move a little bit to the left, yeah? And small block will move a little bit to the right, yeah? Do you see that? Okay, I'm gonna now draw these things again. So look, what I did last time, I said that these parts don't matter. These parts don't, this doesn't matter, this doesn't matter, this does not matter, and this doesn't matter. Do you see? Only these parts of the rope matter. Or maybe this one even, yeah? Why? Because look, I will just put the same colors here. They don't change their length at all. Do you see? This length is exactly the same as this length. Do you see, Domi? Yeah. That's why we can neglect it, because they don't change length. We can kind of like subtract it from the actual length of the rope. From the modeling standpoint. The only things that change, look, these three red things, they got longer. Do you see? These three red things got longer. And this blue thing, this blue thing got shorter. And this is what we care when we model the system. That blue thing got shorter. You see, because before you can even look at this part, that sub part of that blue thing. You see, it really got shorter. Yeah, and we care about change of that rope. And those green things, they don't change at all. Yeah, they're constant. Yeah. So I don't know. I think a strange feeling that I'm talking too much. Did I make you more confused? Yes, you're okay. All right. Any other question? Okay, guys. So thank you for today, and hope to see you on Friday. Okay. Bye.